一样防着自己人。相反这个高等印度人、中等印度人、低等印度人，只要有机会就拼命的往这里整。不管是在欧洲加拿大是吧，包括 America 包括新加坡，都是这么一个战略。那么现在目前呢，新加坡的户籍人口华人还有80%，其实也在不断的掉了对吧？之前90%多但是要看新加坡的非户籍常住人口，那就非常的惊喜了新加坡目前的非户籍常住人口呢200万人200万人，其中呢印度人是大头，然后是马来西亚人，马来西亚人当然有华人，其实这里边马来西亚的穆斯林数量也不低然后是菲律宾人菲律宾人，但新加坡对华人对吧？包括中国大陆的这个严防死守严防死守。对吧？那么按照这个趋势发展下去就要被印度人和马来人联合绞杀了，对吧？联合绞杀了哎呀，这个不知道是好事还是坏事当然我们从另一个角度讲，新加坡的华人也根本不是华人，但是不是不重要，是不是不重要，对吧
I hear ya。
反正我记得这个李光耀的儿子吧，叫李显龙吧，之前也说过很多次，不管华人、印度人还是马来人，大家都是新加坡人来了新加坡就是新加坡人。这个真是团结人团结人。我估计也是受民主党的政策影响的吧，是吧？而且怎么说呢？这个我们不知道是李显龙被卧底耍了，还是如何事实上，在李显龙时代呢，新加坡和印度的。两国签署了协议，就是两国互相开放工作许可，对吧？其实也挺可笑的。这个事情我们都能完全想象得到，对吧？互相开放工作许可，这个协议是对当下新加坡的局面，的形成呢是起了很重要的作用的，就是大量印度人涌入新加坡。虽然现在呢新加坡华人还是占主体，但是这几年我们看，不管是印度还是马来的穆斯林的增速这个增速，对吧？这个增速我觉得新加坡斯坦还没有感受得出来但是我觉得像美国的右派呢，对这个美国的这个对吧，这个白人的主体，现在美国白人就是绝对的主体，但是这个增速对吧，你这个增速下去也是怎么说呢，也是挺吓人的，也是挺吓人的。虽然新加坡也试图遣返一些阿斯兰，但是遣返的也并不多。前两天我看遣返40个，但是相对于来的这个数量呢还是过于的小。而且这个新加坡一方面标榜自己自由民主的资本主义国家，又完全是一一个封建权威和世袭，这个是，对吧？就是也非常的矛盾的，非常的矛盾的。而且我看目前的新加坡似乎真的觉得，不管是华裔、印度裔、马来裔大家都是新加坡人，对吧？但是说起来似乎很团结但是在这个印度裔马来裔之上呢还真都当新加坡人。但是这个华人呢，华裔吧，依旧是严防死守。这个我们这个华人呢，在这个世界上也是独一份也是独一份的，尤其是离岸华人，对吧？这个在这个全球都是独一份的。即便是对吧，这个发展程度距离中国大陆还差得很远，不管是新加坡呀不错了，不管是印度还是中东对吧？甚至还是非洲都没有这个情况。这个包括当年的这个欧洲人也一样，欧洲人大量往北美、往亚洲、印度殖民也一样从来没有出现这种离岸。哎呀，这个事情对吧？你都不用说太远了，新加坡这周边这个台湾、香港，这个思维是如何形成的？你说是殖民地的原因吗？这个印度当年也是殖民地甚至这个全国都被殖民了，那也没有形成这个样子这就非常非常的奇怪不管是印度，包括或者是中国穆斯林或者其他的，包括黑人对吧？或者到欧洲、到美国都是反客为主的，对吧？都一定要强调自己文化的主体性比如印度的英国首相对吧，也一定要大张旗鼓的去过的印度的排灯节反而这个华人到海外就似乎就要把自己的文化主体就要给整没掉给整没掉。这个非常的奇怪，非常的奇怪，对吧？而且这个当年周受资在美国国会这个对吧？这个美国共和党议员问他对吧？这个是不是中国人？他说新加坡人，还说你是中国人。似乎当时大家都嘲笑这个议员没有常识，但事实上这个背后反映的并不是常识的问题，而是在很多美国人的眼里新加坡呢就是中国，就是 China 他有一方面呢似乎想尽办法要摆脱这个呢就慢慢的要造成这个逐步就要被是吧？就要被这个怎么说呢就要被也许吧 再过个20年、30年啊，新加坡就要变成3加河了，或者1加河了。这个最终逐步就要搞成这个样子啊，就要逐步搞成这个样子。这个就是一件非常奇怪的事情，就怎么看怎么扭着吧，怎么看怎么扭着吧。所以这不仅仅是新加坡的问题，整个离岸华人，如果是很多香港的、台湾的，甚至是这个海外的啊，海外的这个离岸华人呢，就往往是这个样子啊。就像我总看推特的都是讲这个到了欧美啊，这个海外的啊，你不管说是反对好、语音好，对吧？要么你到了这儿就要互相和中国大陆切割关系，然后不要说中文，但是这些人又天天活跃在中文自媒体上，你别说中文，你别给我们搭理我们了，啊，又不是，这就总让人觉得怎么说呢，又拧巴又搞笑啊，非常的搞笑啊，非常的搞笑。那好了吧，这个视频就录完了。总之，这个新加坡这种扭着啊，还有搞笑，对吧？还和这个中国人，甚至包括整个华人群体的交流，总是带着一种防备心理和一种划清界限的心理。但是界限呢，又划不清，然后划来划去的，啊，慢慢的呢就要被阿三啊给占据了，慢慢的呢就要变成1加河了，以后我们叫3加河或者1加河。那好，今天的视频就录完了，喜欢的请订阅一下。
There's a storm on Saturn that's been raging for centuries, and it's shaped like a perfect hexagon. No one knows why. And beneath those swirling clouds, something far worse is happening. Something that would kill you in ways you can't imagine. Saturn looks beautiful from Earth. Through a telescope, it's the jewel of our solar system. Those rings catch the light just right. And for a moment, you might think it's peaceful, elegant, safe. But that's the trap. Because Saturn isn't a world. It's a nightmare disguised as a planet. And the closer you get, the more you realize that everything about it defies the rules we thought governed reality. Let's start with what you think you know. Saturn is a gas giant. It's the 6th planet from the Sun. It has rings. It's massive, big enough to fit over 760 Earths inside it. These are facts. They're comfortable. They make Saturn feel predictable. But here's what those facts don't tell you. Saturn is so strange, so fundamentally wrong in ways that contradict our understanding of physics, that scientists still argue about what's happening beneath those clouds. And the more we learn, the worse it gets. The first sign that something is deeply wrong with Saturn is its density, or rather, its lack of density. Saturn is the only planet in our solar system that can float on water. Think about that. A planet floating. If you could find an ocean large enough, and we're talking about an ocean millions of kilometers wide, Saturn would bob on the surface like a beach ball. Its density is just 0.687 grams per cubic centimeter. Water is 1 gram per cubic centimeter. This shouldn't be possible for something so massive. It's as if the universe made a mistake when building Saturn and forgot to add the inside. But this is where it gets worse. That low density means Saturn isn't solid. Not even close. There's no ground to stand on. No surface to land a spacecraft. If you try to descend into Saturn, you wouldn't crash. You just keep falling, and eventually you get crushed so completely that your atoms would merge with the atmosphere itself. You wouldn't die. You'd dissolve. Let's say you're in a spacecraft approaching Saturn. You're still far away, millions of kilometers out, and already you can see the rings. They're stunning. They stretch out 282,000 kilometers from the planet's center, but they're impossibly thin, only about 10 meters thick in some places. From a distance, they look solid, like a disc. But as you get closer, these aren't solid at all. They're made of billions of chunks of ice and rock. each one orbiting Saturn independently. Some pieces are as small as grains of sand, others are as large as mountains, and they're all moving at different speeds, colliding, fracturing, grinding each other into dust. At first, this doesn't seem like a big deal. It's just debris, a cosmic accident frozen in orbit. But then you learn the mystery. No one knows for sure how old Saturn's rings are. Some scientists think they formed with the planet for 0.5 billion years ago. Others believe they're young, maybe only 100 million years old. That's recent. Geologically speaking, that's yesterday. If they're young, something catastrophic must have happened. The moon could have wandered too close and been ripped apart by Saturn's gravity. Or maybe two moons collided, shattering into a trillion frozen fragments. Either way, if the rings are young, they won't last forever. They're falling into Saturn right now. Slowly, inevitably, in about 300 million years, Saturn will and what remains will be far more terrifying. You continue your descent. The rings are behind you now. Ahead, the atmosphere of Saturn is. It's a swirling mass of yellows, browns, and golds, with streaks of white clouds racing across the surface at speeds that would tear apart any structure humans have ever built. Wind speeds on Saturn reach 1,800 kilometers per hour. That's 5 times faster than the strongest hurricanes on Earth. And unlike Earth, where hurricanes eventually die out, Saturn's storms never stop. They feed on the planet's internal heat, growing larger, faster, more violent with each passing year. But here's the problem. You're not even in the atmosphere yet. You're still in space, still safe inside your spacecraft. And already, the environment is starting to kill you. Saturn's magnetosphere, the invisible bubble of magnetic energy surrounding the planet, is the second largest in the solar system, after Jupiter's. It extends millions of kilometers into space. And inside that bubble, radiation levels are catastrophic. Charged particles from the sun get trapped in Saturn's magnetic field and accelerate to nearly the speed of light. If you were exposed to this radiation without protection, your cells would begin to break down within minutes. Your DNA would shred, your organs would fail, you'd be dead long before you reach the clouds. But let's assume your spacecraft has shielding. Thick walls of lead and polyethylene that block the worst of the radiation. You descend further. The atmosphere is close now. You can see individual cloud bands wrapping around the planet like stripes on a spinning top. And then you notice it, the hexagon. At Saturn's North Pole, there's a storm. But it's not shaped like a circle. It's a perfect hexagon, 6 straight sides. Each side is about 13,800 kilometers long, wider than the diameter of Earth. And it's been there for decades, possibly centuries. We don't know how long, because we only started observing Saturn closely in the 1980s with the Voyager missions.
We've made roadside rescue free with every AMI comprehensive car insurance policy. So am I.
But here's what we do know. It shouldn't exist. Hexagons don't form naturally in fluid dynamics. Storms on Earth are circular. Hurricanes spin in spirals. Even the Great Red Spot on Jupiter is global. But Saturn's hexagon is geometrically precise. The edges are sharp. The angles are exact. Scientists have tried to replicate it in laboratories by spinning fluids at different speeds, and they've had some success. But no one can fully explain why it's so stable. Why it doesn't drift or distort. Why it looks like something designed rather than something formed by chaos. And here's where everything changes. Inside the hexagon, there's another storm. A smaller one, circular this time, sitting at the exact center of the pole. Its eye is dark, deep, and around it, clouds spiral at speeds we can barely measure. This is Saturn's polar vortex. And unlike Earth's polar vortex, which brings cold air and snow, Saturn's vortex is a furnace. The temperatures inside are hundreds of degrees hotter than the surrounding atmosphere. No one knows why. The heat doesn't come from the sun. It comes from below, from inside Saturn itself. You descend into the upper atmosphere. The first layer is calm, deceptively calm. The pressure here is similar to Earth's surface. You could, in theory, open a window and breathe. Except you'd be dead instantly. The atmosphere is 96% hydrogen and 3% helium. There's no oxygen, no nitrogen, just two of the lightest elements in the universe, packed together so tightly that they behave like a liquid in the deeper layers. As you sink lower, the pressure starts to build. Slowly at first, then faster. The spacecraft's hull groans. The temperature outside is dropping, minus 180 degrees Celsius. The clouds around you are made of ammonia ice, crystallized poison floating in the air. Ammonium hydrosulfide. It smells like rotten eggs. The kind of smell that would make you vomit if you could smell it through your suit. But you can't. You're sealed inside, isolated, alone. And then something worse happens. The pressure doubles, then doubles again. You're 100 kilometers below the cloud tops now, and the pressure is 10 times what it is on Earth's surface. The spacecraft's metal frame starts to bend. Not much, just a little, but enough that you notice. Enough that alarms start flashing. You're not even halfway to Saturn's core, and already the planet is trying to crush you. At 200 kilometers down, the pressure reaches 100 Earth atmospheres. The hydrogen around you is no longer a gas. It's a supercritical fluid, a state of matter that's neither liquid nor gas, but something in between. It flows like water, but compresses like air, and it's everywhere, pressing in from all sides. The temperature has risen now. It's no longer freezing. It's hot, 1,000 degrees Celsius. The spacecraft's cooling systems are struggling. You're sweating. The air inside tastes metallic. But this is where it gets truly terrifying. You're about to enter a region of Saturn that no human-made object has ever survived. Not even in simulations.
On my way.
At 30,000 kilometers below the cloud tops, the pressure reaches 3 million Earth atmospheres. The temperature is 10,000 degrees Celsius, and the hydrogen undergoes a transformation that seems impossible. It becomes metallic. Metallic hydrogen is one of the strangest substances in the universe. Under extreme pressure, hydrogen atoms are squeezed so tightly that their electrons break free and flow like electricity through a wire. The hydrogen becomes a liquid metal, shiny, conductive, and it behaves in ways that violate everything we know about chemistry. It's what generates Saturn's magnetic field. This vast ocean of liquid metal, thousands of kilometers deep, churning and rotating inside the planet. It's the heart of Saturn, and it's completely alien. Your spacecraft can't survive here. The hull collapses. Not slowly.
What can I do for
instantly.
you?
One moment, you're inside. The next, you're not. The pressure crushes you
Now look.
so fast that your body doesn't have time to feel pain. Your bones shatter into powder. Your organs turn to paste. Your blood boils and then freezes and then boils again as the temperature fluctuates wildly in the turbulent metallic ocean. You don't die. You cease to exist. Your atoms scatter. Some get absorbed into the metallic hydrogen. Others rise back up to the surface, carried by convection currents that take thousands of years to complete this single cycle. But let's imagine you could survive. Let's say you had some impossible material, some science fiction shielding that could withstand the pressure and heat. You keep descending, past the metallic hydrogen, deeper, toward the core. And here, scientists argue. Some believe there's a solid core at the center of Saturn, a dense ball of rock and ice, about 15 to 20 times the mass of Earth, sitting at the very heart of the planet.
What's up, boss?
Others think there's nothing, just more metallic hydrogen, getting denser and hotter the deeper you go, until you reach the geometric center, a point in space with no surface, no boundary, just infinite pressure. If there's a core, it's hell. The temperature is estimated at 11,700 degrees Celsius, hotter than the surface of the sun. The pressure is 45 million Earth atmospheres. At this pressure, matter behaves in ways we can't
Let's
predict.
hit him hard.
Atoms might fuse together,
Good to go.
creating exotic elements that only exist for fractions of a second before
I
decay.
got a sensor lock.
They might form new states of matter we don't have names for yet. Superionic
Stand
ice, plasma solids, quantum fluids, things that shouldn't exist, but do because Saturn is so extreme that the laws of physics bend just to accommodate. And then there's the rain. On Saturn, it rains diamonds. This isn't a metaphor. It's real. In the upper atmosphere, lightning storms, thousands of times more powerful than anything on Earth, strike the methane clouds. The intense heat and pressure break apart the methane molecules, leaving behind pure carbon. The carbon atoms clump together and form a sphere. The soot particles fall, and as they fall, the pressure increases. The temperature rises, and the carbon crystallizes, first into graphite, then deeper into diamond. Billions of tons of diamonds, some as large as a centimeter across, raining down through the atmosphere, sinking into the metallic hydrogen ocean below. They fall for thousands of years. Some might reach the core.
Waiting for orders.
Others dissolve along the way, their atoms ripped apart by the sheer violence of Saturn's interior. But here's the part that makes Saturn truly alien. Time works differently there, not in a relativistic sense. Saturn isn't massive enough to warp space-time like a black hole, but in a rotational sense. Saturn spins faster than any other planet in our solar system except Jupiter. A day on Saturn is only 10 hours and 33 minutes long. Think about that. A planet 95 times more massive than Earth, spinning so fast that its equator bulges outward.
What can I do
The
for you?
centrifugal force is so strong that Saturn is visibly flattened. Its equatorial diameter is 120,536 kilometers. Its polar diameter is only 108,728 kilometers. It's not a sphere. It's an oblate spheroid, a squash ball. And because it's spinning so fast, the weather patterns don't just move east to west. They spiral. They twist. They form structures that should be stable, but are. The hexagon isn't the only mystery. There are other storms, smaller ones, scattered across Saturn's surface like scars. In 2010, a massive storm erupted near Saturn's equator. It was a white spot, a designation given to large-scale atmospheric disturbances. But this one was different. It grew and grew. Within weeks, it had wrapped entirely around the planet, a single storm system encircling Saturn like a ribbon. It lasted for months, and when it finally dissipated, it had churned the atmosphere so violently the temperature of the storm's core had risen by over 80 degrees Celsius. Scientists called it the Great White Spot, but it was more than that. It was a reminder that Saturn's atmosphere is alive, constantly changing, constantly violent. And then there are the moons. Saturn has 146 known moons. Some are tiny, just a few kilometers across. Others are massive. Titan, Saturn's largest moon, is bigger than the planet Mercury. It has a thick atmosphere, lakes of liquid methane, weather, seasons. It's the only place in the solar system besides Earth where liquid exists on the surface. But Titan isn't comforting. Its surface temperature is minus 179 degrees Celsius. The lakes aren't water. They're hydrocarbons. If you fell into one, you wouldn't drown. You'd freeze solid before you could sink. But Titan isn't the scariest moon. That title belongs to Enceladus. Enceladus is small, only 500 kilometers across.
Waiting on you,
But
Commander.
beneath its icy surface, there's an ocean. A global ocean of liquid water, kept warm by tidal heat. The gravitational pull of Saturn flexing Enceladus's core, generating friction, generating heat. And from the south pole of Enceladus, geysers erupt. Jets of water vapor and ice particles shoot hundreds of kilometers into space. Some of this water falls back to the surface. Some escapes and becomes part of Saturn's E-ring. But some of it contains organic molecules, the building blocks of life, which means there's a chance, a small, terrifying chance, that life exists in that ocean. Not intelligent life, probably just microbes, but life nonetheless. And if life can exist there, in the freezing darkness beneath an alien moon orbiting a gas giant a billion kilometers from the sun, then life could exist anywhere. The universe becomes less infinite. Somehow, that makes it more terrifying. Saturn's rings aren't just beautiful, they're dangerous. If you try to fly through them, you'd be shredded. Velocities, tens of thousands of kilometers per hour. Even a grain of sand at that speed would punch through spacecraft like a bullet. The Cassini spacecraft, which studied Saturn
Yes,
for 13 years, had to carefully navigate gaps in the rings. And even then, it was pelted by microscopic dust particles that slowly eroded its instruments. When Cassini's mission ended in 2017, NASA deliberately crashed into Saturn's atmosphere. They didn't want to risk it colliding with a moon like Enceladus and contaminating it with Earth bacteria. So they sent Cassini diving into the planet. It transmitted data until the very last second. And then the pressure crushed it. The heat vaporized it. And Cassini became part of Saturn. Forever. But here's what Cassini taught us.
Now it's on.
Saturn is losing its rings faster than we thought. The rings are raining onto the planet. Every second, 2,800 kilograms of
I hear ya.
material falls into Saturn's atmosphere.
You
It's
betcha.
called ring rain, and it's irreversible. In 100 million years, maybe less, the rings will be gone. Saturn will look like a featureless ball of gas.
Roger that.
Forget
Firing
them.
on target.
And whatever made the rings in the first place, whether it was a destroyed moon or a cosmic collision, will be erased from existence. The universe will forget, and Saturn will continue spinning. Empty. Alone. There's something deeply unsettling about Saturn's isolation. It's 1.4 billion kilometers from the sun out there. Sunlight is weak.
Good to go.
Pale. A human standing on one of Saturn's moons would see the sun as a bright star. Nothing.
Targeting towards
There's no warmth, no comfort, just cold and darkness, and the slow, grinding rotation of a planet that doesn't care whether you exist or not. Saturn doesn't need you.
Moving out.
It doesn't need anything. It's been spinning for 4.5 billion years, and it will keep spinning long after humanity is gone.
$14.99 for all this.
Save money. Move out of your parents' place.
That's more of a flatting search.
So you're on your flatmates.
And yet, we're drawn to it. We send spacecraft. We build telescopes. We write papers and theories and simulations, trying to understand why Saturn is the way it is, why the hexagon exists, why the rings are so thin, why the storms never stop. But every answer we find just leads to more questions. And the more we learn, the more we realize how little we actually know. Saturn isn't just strange, it's unknowable. A mystery wrapped in hydrogen and ice and metallic oceans that we'll never see, never touch,
Hell yeah.
never truly understand.
Waiting for
But the
orders.
scariest part isn't what we don't know. It's what we do know. Saturn is a reminder that the universe doesn't operate on human scales. It doesn't care about our survival, our comfort, our need for things to make sense. Saturn exists because the laws of physics allow it to exist. And those same laws could create things far worse. Planets where the rain is sulfuric acid, where the atmosphere is so thick that light can't escape, where the gravity is so strong that time itself slows down. Saturn is just the beginning, a glimpse of how hostile the universe can be. Imagine what else is out there. We've only explored a fraction of our own solar system.
Ready for
Beyond
orders.
Saturn, there's Uranus, Neptune, the Kuiper Belt, and beyond that, the Oort cloud, a shell of icy debris stretching halfway through the star. And beyond that, interstellar space. And beyond that, other stars, other planets, billions of them, trillions, each one governed by the same merciless physics that created Saturn. Some will be similar, some will be unimaginable, and we'll never see most of them. We're too slow, too fragile, too bound to this one tiny planet orbiting an average star in an unremarkable galaxy. Saturn doesn't care. It spins. It crushes. It rains diamonds into an ocean of liquid metal. And it does